Hey everyone, and welcome to this webinar on data analysis in Python with Pandas. Thank you for joining this morning, afternoon, or evening, depending on where you are in the world. I'm thankful you can spend the hour with me, and I hope you'll learn a little something along the way. I'm Jonathan Wood, a consultant here at Wintellect. My Twitter is @jwood if you'd like to get in touch afterwards with any questions. Now, a little bit about Wintellect if you aren't familiar with what we do. We're a consulting and training company. For the training side, we offer instructor-led training as well as on-demand training with Wintellect Now. For data science courses, we have a few items on Wintellect Now already, but there is plenty more in the works, so be on the lookout for those. So what we're going to do today is that I'm going to introduce and show you how to install Jupyter, Pandas, and Python if you already don't have those installed. And then I'm going to introduce and go over some Numpy basics. And understanding Numpy will help you quite a bit in understanding Pandas. And then for the Pandas part, I'm going to kind of simulate a data analysis project and kind of show you different ways to load data, how to get descriptive statistics, which can tell you a bit more about your data, and how to go through missing and duplicate data, how to handle those and different ways in which you can handle those. And then go over some column operations, such as creating new columns based off columns you already have in your data, and aggregating your data so you can gain some additional insights upon your data. And then we'll end up on some visualizations, different ways we can visualize our data and how that may help us understand our data just that much more. Now, before we get into all the content here, I'd like to ask y'all a question. How much Python experience do y'all have? And I'll wait a few seconds to let y'all answer that. So it looks like most of y'all don't have too much experience with Python, so with that, I'll do my best to explain not only the Pandas syntax that I have in my demos, but also some of the more Python-centric syntax that I have there. Now I'm going to be using Jupyter to show my demos here, and if you're not familiar with Jupyter, the best way to think of it is basically a web-based platform for data and scientific computing. This includes having code, text, and even visualizations into a single notebook. Two things I want to highlight from this are the web-based and scientific portions. For the web-based part, this means that you can share your notebooks very easily, especially now that GitHub renders notebooks online so you don't have to clone the repository just to view it. And for the scientific part, notebooks allow, along with the sharing part, to allows your code to be reproducible, which is an important part of the scientific community. Now let's go into a little bit of a demo and show you, in case you already don't have Python or any of the packages already installed, and how you can install those. Alright, to install Python in Jupyter, we're going to use a distribution called Anaconda. Now Anaconda comes with, like I mentioned before, it comes with Python, Pandas, Jupyter, and all sorts of other packages that you would use for data science and machine learning. So to download it, you go to anaconda.com and go to the download button. And as you can see here, you can download Anaconda for whatever operating system that you're using. Now scroll down here and you see we'll have two different download choices here. We can either use Python 3 or Python 2. Now, if you reference any of the older books or articles, they're going to mention to use Python 2. But nowadays, in the past maybe a year or two, all the packages that you will be using have been upgraded to Python 3. And I definitely recommend Python 3. The Python 2 support is pretty much gone other than security. So, and I have yet to find any issues using Python 3, so definitely recommend doing that. So you would hit download, and once you install that, you would open up your terminal and you would just type in Jupyter Notebook to launch the notebook server. But also I'm going to be using what's called Jupyter Lab here in my demos. Jupyter Lab is actually pretty much the next version of Jupyter Notebook. The Jupyter team pretty much just taken all of the feedback and feature requests for Jupyter Notebook and just kind of split it off into another project. Alright, now that we have everything installed that we need, let's go back to the slides. And talk a little bit about Numpy. Now, Numpy is pretty much the base package for a lot of data science related libraries. Not only Pandas, which I'll be showing you a little bit how that Pandas uses Numpy in a bit, but also scikit-learn for machine learning, TensorFlow for deep learning, and a bunch of just other packages that we'll be using kind of numerical analysis. And some features that Numpy gives you here is it can handle large and multi-dimensional arrays. Now, what I mean by handle large arrays is that it can compute those arrays very fast, and it also includes a few random generation methods in case you need to make some quick dummy data to play around with, and it includes libraries of mathematical functions, including some linear algebra functions. Now, we won't be getting into the linear algebra in this webinar, but mainly because it's been at least 10 years since I've messed with linear algebra, so I'm sure I have quite a bit of boning up to do before I show anybody how to use those things. So now that we kind of know a little bit what Numpy is, let's go over some code to kind of show you some of the features that it gives you. So I'm going to go over to my Jupyter Lab here and have a notebook for you. Now, I mentioned before that Pandas uses Numpy for a lot of the operations that it uses, and the main thing you'll be using from Numpy are the arrays that it has. The first thing we need to do is import Numpy, and we'll do that. You'll notice this way we're importing it as NP. You'll see that in pretty much all of the reference material that you'll be looking at. And we can easily create arrays in NumPy with the np.array function. And here, if you come from other programming languages, this looks like an array itself, but in Python, it's just a list, which is pretty much an array that can have different types inside of it. So we do that, and of course we get back an array, and we can double check the type of the array, and there it is. It's a NumPy ND array. The ND stands for n-dimensional. Now, for numerical analysis, you'll have all these arrays, and you want to do different operations on them, such as mathematical operations. And pure Python, if we try to do that, try to add two lists together, all this is going to do is concatenate those two lists, which is not exactly what we want for our numerical analysis here. But NumPy, if we take those two lists in Python and create NumPy arrays with them, and we add them together, then we get exactly what we intend here for those two arrays to be added together. Now, I mentioned before that NumPy arrays are very fast, and one of the reasons it can be is that it kind of coerces all of the elements inside the array to be the same type. So, for example, here I have a Python list here with two integers and a string. And if you create a NumPy array with those, what we get is that it kind of coerced all of those elements to be strings. Now, what happens if we take our original NumPy array with integers and we try to add an array of strings? Well, NumPy doesn't like that. It's going to give us an error saying that the types don't match. And of course, NumPy gives us some methods here that we can use to kind of cast the different types, and that gives us what we need there. And just to show you a bit about some multi-dimensional arrays, we can create 2D arrays, and we can also create 4D arrays, and we can go up as many dimensions as we need to for our data. And quickly want to highlight Jupyter here. It kind of pretty prints our arrays here, so it looks a bit more like a matrix, which is a lot easier to read than if it just printed out the arrays in a single line. Again, if you come from other programming languages, you may be familiar with array indexing and array slicing, and kind of just to highlight a little bit of what for one thing, that those things can be done with Numpy arrays, but also Python itself has some interesting ways in which we can do those things. Now, if we look at our first array that we created, we can get the second element because Python is a zero index based array language, but also we can give it a negative index, and what that does is it traverses backwards into the array. So if we give it -1, it'll give us the last element in the array. Now, if array slicing to get subsets of arrays, Python gives us interesting syntax here. General syntax here is that within the brackets we can give it kind of a start index separated by a colon, then a stop index separated by another colon, and then kind of the step or the increment that we want to get the items in the slice. So if we do this, we get the first two items. And now each of these items can be omitted here, so we can not put in the step part here. We get the same array that we did. We can omit the start index, and we'll again get the same array. And we can also omit the stop index, so we get the array from the first index on to the end. And up here we get it defaults to 0 here. But slicing is not limited to just one-dimensional arrays. We do it on 2D arrays as well. And here, just to kind of reference the 2D array we created earlier, and slicing is a little bit different. We just separate the slices on each dimension by commas. So if we just wanted all the rows and all the elements in all the rows in only just the first column, we can do that. And the first row in all columns, we can do that. And if we can pinpoint just a single element, we get the second row and the second column. And I mentioned some random methods that Numpy provides us. A couple that you'll see a lot is the random.ranInt, and the parameters here is the highest number, highest random number to choose from, and then the size is what the size of the array that we want to return. We also have the random.seed method, which allows for reproducible results. For instance, if I run this and then run this ranInt method for 0 and 3, if I do it again, once again I get 4, 0 and 3. So it just allows for if you share a notebook with uses random generations, you put a seed in there, and then everybody who runs it will get the same random sequence. Alright, so that's a little bit on Numpy to give you some basics on kind of how to work with that, and some features that it provides you. We'll go back to the slides here. Alright, so now that we've we're about to hit up on some pandas. Just another question for all of y'all. Have y'all heard or just maybe kind of worked with pandas before? And once again, I'll give y'all a few seconds to answer that. Alright, so it seems most of y'all haven't worked with it before, which is probably why you're here. And once again, I'm glad you're here, and I hope you learn a lot, or at least just a little bit that's interesting through this webinar. So first of all, what is pandas? Now, there's kind of a running joke in the data science community where you spend most of your time kind of cleaning and working on the data itself. And this tweet by Jake Vanderplas, who, by the way, is pretty well known in the data science community. And if you have a chance, definitely look him up on YouTube. He has a few really great talks that I highly recommend. And here he says, cleaning your data is 90% of the work. Fitting your model is easy. And I can definitely attest to that myself. Most of the job is going to be maybe getting the data and then working with the data to kind of get it into a format where you can actually put it into a machine learning algorithm. And so this is where Pandas comes in. And it's pretty much a library for fast and easy data analysis and data cleaning and munging and all that. And once again, it's built on top of Numpy, and I've gone through some of the source code of Pandas, and I can definitely tell that it uses Numpy quite a lot. And so a few things that Pandas will provide for you is some methods for loading of external data from many different formats, and I'll show a little bit of that in our demos. And we get some easy ways for data manipulation, including you can easily create new columns based off calculations from current columns in your data. And also it integrates Matplotlib, which is a graphing package for Python, and it integrates that for visualizations. And we're going to see all this and a bit more in our demo that we have coming up. So now I'm going to go back to Jupyter Notebook, and I have a notebook for everything we're going to do in Pandas. First of all, of course, we need to import Pandas, and I like to import Numpy as well in case I need to use that. Sometimes I usually do within my analysis. And I have a data set here I'm going to be using to show you everything here. And Pandas comes with a lot of methods where you can read from. I'm reading from a CSV, and all I need to provide it here, it is a simple CSV file, but few times all I need to provide is where the CSV is located on the file on my system, and maybe a delimiter parameter as well, but oftentimes that's about it. So I'm going to load that, and here's our data we're going to be working with for a bit. I'm sure you can see a couple of things wrong with this. We got some nans, negative 999. We're going to show you different ways on how to deal with that. Real quick, a couple of methods I use probably the most when I'm messing with Pandas is first of all, to get kind of a idea of first few rows of the data set, is I use the head method. This defaults to returning the first 5 rows. You can put in an integer in here and it will return that instead. On the other side, you can get the last number of rows, and here return the last 2 items of the data. And what I usually like to do, especially before I start doing some data analysis on it, on the data frame there, is that I like to make a copy of it with just the copy method. The reason for that is, sometimes, or well, most of the time on the data frame, I'm going to be creating new columns, dropping columns, and manipulating a bunch of the data within the columns. And so if there's ever a point where I go, it's like, all right, I messed up this data frame. I just need to go back to the beginning, and instead of going all the way back up in my notebook and running through different things at the same time, I can just automatically have a copy of it here that I can just go right back to it. I want to go back here. I mentioned those read methods earlier, and they are quite a few of them. And so we'll look at the API reference for Pandas here, and there's just a bunch of whatever data format that you have. There's a good chance that Pandas has a method to read it for. So we use the CSV method here. You can read from Excel, spreadsheets, JSON if you're calling an API, and HTML if you're doing some web scraping, and a bunch of other stuff. Some SQL, you can read SQL or SQL tables. And on the other side is you can not only can you read from it, you can write to those to disk as well. So Pandas gives you some really good options for that. Now, just to kind of show you our values here, and I guess to kind of prove to you that Pandas is using NumPy, and the behind the scenes here is that our values itself is using as a NumPy ND array, and if we get the first array of values, it's also a NumPy array. Now, one of the things you're probably going to be doing the most when cleaning up your data is how to handle missing and duplicate data. So let's look at our data set a little bit here. And so let's first handle this -999. Now I want to highlight this part especially because not all of your data that you need to clean up is going to be missing. And so it's easy to find missing data, but this type of data where it may not make sense in terms of the type of data that you're collecting. And I'll give you two examples on that I've come across. The first one is there's a data set out there called the Pima Indian diabetes data set, and that was taking some vitals on some people to kind of and determine if they have diabetes or not. Now, in that data set, there would be some columns called blood pressure or insulin count in there, and some of those would be 0. Now, I'm not a doctor and I don't play one on the internet, but if somebody has a 0 blood pressure, I'm pretty sure something might be wrong there. Another example that I've come across is I was playing around with some data on beer a while ago, and I found there was this one beer in there, and his alcohol by volume, his ABV was 80. If you drink something that has 80% alcohol by volume, and that's probably not going to be very good either. So just really want to reiterate that not all the data that you would need to clean up is going to be missing. And in our case, we can just use the simple replace method here. And so in this case, it might be that somebody entered in a wrong number for data entry, or maybe it was scanned in and it was read wrong or something like that. So there we go. So we replace that one there. Now for our missing data, Pandas does make this very easy. We can check items that are null, we know the values, and if any of them are null, and indeed we have some values that are null or missing, and it's denoted in Pandas by nan, which is not a number. It's a special floating point value. So we determined that there are some missing values, and we can do kind of a similar query than what we did before to ask Pandas to give us back the rows which include those the missing values. So we do that. Indeed, we have our 2 rows that have missing numbers, and here we're again checking if any values is null, and this axis equals 1 means to check on the columns. I can also, to make it a bit more clear, I can put in columns in that as well instead of 1, and just kind of show you what's going on up in here a little bit. First is if I want to find all the rows where the item sold is less than 5. And Pandas returns not the rows, but it returns an array where this expression is true. Now, to get the actual rows back, we need to do a Boolean selection and just encapsulate our condition inside of our Dataframe selector here. And there we go. Now we have our rows that have items sold less than 5. Now we handled our -999 there, so now we can handle our actual missing data. And then there are a couple of ways in which we can do this. You can just drop the rows or columns entirely that have the missing data. This is a bit of a last resort though, because that also means you're dropping data for other columns, and the more data that you have, the more accurate your models and your analysis is going to be. Although if you have 2 million rows and maybe 3 of those are have missing data, then it probably wouldn't cause too much of an issue to drop those. But another thing you can do is actually fill in the missing data with other values. So first of all, to show you in Pandas how to drop null values, null rows, is very simple. We have this drop NA method. If you run that, then those 2 rows are now dropped. Now, filling in our missing values, it can be tricky, and this is where having some domain knowledge of the data that you're working with comes very much in handy. And a couple of methods that are pretty common out there is kind of taking the mean or the median of the column and replacing the null values with that. So what I'm gonna do this differently in 2 different columns. The first column, our items sold column, I'm gonna just call this fill in a method, and I'm gonna get the mean on that and just fill it in with that. This in place equals true. If you remember up here when we did our data frame equals whatever method we're calling, we don't always have to do that. We can just put in a parameter that says in place equal true, and it does it in place, and so we don't have to set it equal to anything. For our order date though, we can't really get a mean value of that, so I'm just going to fill it in with a hard-coded value here, and now that handles our missing data. And Pandas also has some great support for finding and dropping duplicate rows. It comes with this duplicated method, and once again it gives us this Boolean array that we've seen before. And look, we have our last row here is a duplicate of another one, and we can do our Boolean selection here on that, and so we can see which row it is. Indeed, it is the last one. And we can call this again with this keep equals false parameter. And what that does is that not only is going to give us our duplicated row, but it's also going to return back the original row that it was a duplicate of as well. And to drop the duplicates, all we have to do is just call the drop duplicates method. And there we go. As you can see, Pandas provides us some very easy APIs for handling a lot of data manipulation. Another thing you will probably want to be doing for your data analysis is changing column types, usually from strings to integers or integers to strings, so you can do different analysis on them. We can call it the dtypes attribute here to kind of give us an idea of the types of our columns here. The first two are floats and the last two are objects. And it's worthwhile to note here the strings, this is a Numpy thing here, but strings are denoted by objects instead of just a string type. Now for dates, Pandas offers us a toDateTime method, and this is just a warning here from Pandas, and you can see it changed our dates around to actual datetime type. For other types, we can just on our column that we want to change, we can just call the asType method and then give it the type we want to cast it to. And we went from floats to integers in our items sold column. And along with the dtypes attribute, there's also an info method that we can call. Gives us a little bit more information than just the types. But we can see here the items sold now is integers, and our order dates are now date times. Now, different ways for your data analysis, you can do some aggregations and handling data in other ways to get some insights on it. Grouping is going to be a popular way, and to do that in our data frame, just call it group by and give it a column name here, and I'm getting the sum of the groups, so it gives us that. Now if we just leave out the sum here, it's just going to give us a data frame group by object, and so it doesn't know what to do with that, so we need to give it some sort of aggregation method. Now we can also sort values on this as well. So I'm going to do the same group by on the salesperson and get the sum of those, and I'm going to sort those values by item price, and I'm going to sort by descending. Yep. So that sorted out items price and it grouped by salesperson. Now you're not limited to just grouping by one column. You can group by multiple columns, putting the column names in a list here. Now what this does though in Pandas is that it's going to give you a multi-index, and what that means is that there's more than one index, and so and Jupyter helps us out by giving us some nice visualizations. And so our first grouping is by salesperson. You see, then our second grouping is about order date, which is what we specified up here. And so we can easily see different groups that way. You can also concatenate different data frames together. So let's say I have this some new data came in, maybe from a web page or something like that, and I want to add it on to the data frame from our old data, our archive data, so we can do models against all the data at once. And for this, it's real easy. Just call the concat method and give it both of our data frames. And now we have both data frames in one. But you probably notice our index here. It uses the index of each of the individual data frames, so it went back to 0, which is the index up here in our second data frame. This is easy to fix just by calling the reset index and the drop true. And the drop true will make it so the index doesn't become another column. And there we go. Now our indexes are fixed. This could be helpful if you're maybe doing time series analysis where the indexes are maybe dates. So you actually use the index. Now it's easy in Pandas to create calculated columns. So let's look at our data frame here. And so we have our items price and our items sold, but what about, we don't have anything that tells us the total price of what our salesperson has sold. So we can create that on our own. We just create a new column right here, and we just do our column operation here. And if you remember back in our Numpy demos there, this is pretty much the same thing that's going on there. And now we have our new column of total price. Now I want to mention a couple of statistics things, and we're not going to do too much statistics, and I'll explain as much as I can here. First thing I want to show is dummy variables. And dummy variables is a way to represent categorical variables as numbers. And the reason you would do this is all these machine learning models and statistical models, they're just algorithms or formulas, mathematical formulas, and they don't know how to handle categorical data, which is text. And in fact, if we try to run this data in a scikit-learn machine algorithm, it's going to error out on us, and it doesn't know what to do with these values. So that's where dummy variables comes in. And run this real quick, kind of show you exactly what it's doing. Well, what it's doing here is that for each categorical value it sees in a column, it's going to create a new column for it, and for which one it matches up, it's going to put a 1 and then a 0 for everything else. And we can specify the columns we want it to do that on its own, and here you can get a better sense of what it's doing for dummy variables. So our first two here are John is our salesperson, and we can see that it's up that way up here in our original data. Pandas makes it easy to get some descriptive statistics, which are just some values that kind of are easy to get on our data, but they also they can tell us a lot about the data as well. Easiest way to do that is just call the describe method on your data frame, and we have quite a few things here and it tells us a lot. Our mean or average values here for each of our columns. Notice here the only columns we're getting back here are our numerical columns. It's not going to do this on categorical columns. And again, the min and max, this is actually where I found those issues I mentioned earlier about making sure you handle data that's not missing but doesn't make sense in terms of the type of data that you're getting. You can call describe on a specific column here on item price, and I can call some other methods here for other statistical methods here. For instance, the mean, I can call it by itself, the median or the middle number, the standard deviation, which tells you how spread out the data is. And another very useful statistical method here is called correlation. Now, what this is going to do is going to give you kind of a number between -1 and 1 between each the numerical columns. Of course, there's 100% correlation of the item onto itself. So you're going to see this kind of diagonal going down of ones. And for the closer to 1, you're going to have a high positive correlation, and the closer to -1 is going to be a high negative correlation. And the higher the correlation is, the more linear this relationship is. And touch a little bit on visualizations. Pandas utilizes matplotlib, which is a very well-known graphing package in Python, and it's been around for a long time and very battle tested, which means you know it's pretty much going to work. I'm also importing Seaborn, which is kind of built on top of matplotlib, and it makes the graphs a little bit nicer, and it also gives us some additional methods for other graphs, more statistical graphs as well. To use Seaborn, you do have to do that set method on it. And this matplotlib inline here is in Jupyter is called a magic command, and what it's telling it is that to kind of inline the graph's output into the notebook itself instead of showing popping up a new window with the graph. So we'll run this, and matplotlib again is built right into Pandas. So on our data frame, we can just call plot, and it does its best to give the best kind of plot that it can with the data that we have. In this case, it's just giving us line plots. It offers several different types of plots that will be quite useful, such as scatter plots. And scatter plots are used a lot for two numerical variables, and bar plots, which is used a lot for categorical variables. And you can also do a bit more advanced plots, such as a box plot. And the way that, if you're not familiar with how to read this, it can actually tell you a good bit about the data. And first, this is total price column here. This bottom line here is the min value. The top one is the max value. This red line here is the median value here. This bottom box is the 25% percentile. The top one is a 75th percentile. And sometimes you may see some dots maybe above or below these lines, which tell you that there are some outliers. We also can get a density plot. Density plots are pretty much, they're like histograms, but the lines have been smoothed out. We can plot by single columns as well to get a better idea of just that single column of the data. And we can plot on grouped data as well. So that query we ran before, where we grouped by salesperson and sorted by the item's price, we run that, we can get another graph here, which can tell us a lot different things about our data. And just to kind of end up a little bit here, you can customize your plots as well. A couple of things that you'll find the most often are adding labels or axes labels to our plots to make it a bit more descriptive. And we can change colors of our plots here to kind of make it stand out a little bit more. All right, so that's pretty much an introduction to a bunch of things that you can do in Pandas. Going back to the slides. So just to kind of leave you off some additional resources in case you want to learn some more. And you can do some Google searches, but I'm a fan of books. Still a fan of physical books, and two of these here I very highly recommend. The first one here, Python Data Science Handbook, is written by Jake Vanderplas, who I introduced earlier in that tweet. And in fact, here you'll see this powered by Jupyter. And what Jake did for his book, he wrote his book entirely as Jupyter notebooks. So in the resources that we'll have, I'll have a link to the website where you can find a bunch of those. And this other one, Python for Data Analysis, the second edition was just released a few months ago, so it's quite a bit up to date. And Wes McKinney, who wrote the book, is actually the person who created Pandas. So if there is anybody to learn from, it's the guy who created it, right? And I also have a link to that as well in our resources. And a little bit of a call to action for all of y'all is just find an interesting data set and play around with it. See what kind of questions you can ask the data, and use Pandas to help you answer those questions. And to help you get started, I got some links to some where you can find some data sets. The UCI Machine Learning Repository is a popular place for mainly machine learning data sets, but you can definitely do some analysis on those. In fact, this is where that Pima Indian diabetes data set is located that I mentioned earlier. Reddit has a bunch of things, and include as well as data sets community, so people curate some stuff and put it on that subreddit. Kaggle data sets, they're mostly for machine learning, but again, you can definitely do some analysis and on those. In fact, they'll have the competitions, so you can get some pretty real world data to practice on. And GitHub has an awesome public data sets repository where there's quite a lot of public data sets that's been curated into a repository there. And last but not least, any questions there? Once again, feel free to reach out on Twitter at jwood anytime, and I'll get back to you as soon as I can. The notebooks and slides are on GitHub, and last but not least, have fun answering questions with data. So now I'll get on to some questions here.